Students, this question was asked in the year 2021 from the chapter Thermal Properties of Fluids from that is class 11 student, and the chapter number is, let me see what is the chapter number. Chapter number is 10 student. I have not written it here. Chapter number is 10. A cup of coffee cools from 90 degrees centigrade to 80 degrees centigrade in T minutes when room temperature is 20 degrees centigrade. The time taken to cool the cup of coffee from 80 degree to 60 degrees centigrade at room temperature 20 degree centigrade is how much, students? Students, I have already told you, whenever a question is asked in NEET exam, first you have to think what is the formula basing upon which the question has been asked. You tell me, student, what is the formula to be used here now? What is the law or principle basing upon which this question has been asked? Okay, student, that is, tell me, do you remember? That is Newton's law of cooling. Okay, student, that is Newton's law of cooling. What is the statement of Newton's law of cooling? Do you remember, student? That is the rate of change of rate of loss of heat or the rate of cooling of a body is directly proportional to the temperature difference between the body and the environment of the body, or its, we may write, and its environment or surrounding. Okay, student, environment or surrounding. So, student, this tells that dt by dt, t stands for temperature, okay, students, and t for time, small t for time, is directly proportional to t body minus t surroundings or t environment. This is the thing, okay, student, and we may write this like this. Suppose the initial temperature of the body is, let us write T initial. Okay, student, let us write the T initial is the initial temperature of the body. T final will be the final temperature of the body. Then what will be dt by dt, student? That will be T final minus T initial by time taken. Okay, students, and what will be the temperature of the body? The average temperature of the body will be T final plus T initial by 2. Okay, student, minus temperature of the environment. This will be directly proportional to this one, or we may write this as K into this much, where K is a positive constant according to Newton's law of cooling. This K is a positive constant that depends upon the area of the surface through which the heat is flowing away, students, and its nature of the surface. We know, we have studied the Newton's law of cooling, students. So we may write mathematically Tf minus Ti is equal to K into Tf plus Ti by 2. Let us write this in bracket, minus T environment. So in this situation, we shall apply this formula, student. In the first case, student, that is T final is 90 degree, T initial is 80 degree, and T environment is 20 degree. So let us write the equation here. That is 90 minus 80 by T is equal to K into 90 plus 80 by 2 minus T environment. What is the Tm friend, that is the room temperature, student, that is 20 degrees centigrade. So student, this becomes K into this is 90 plus 80 minus 40 by 2, or this is 170 minus 40 means 130 by 2, or that is 65. So 65K is equal to how much? 90 minus 80 by T means 10 by T. Okay student, 10 by T, or student K is equal to 10 by 65 T. 65 T, or that is equal to student, we divide this by 5, so this becomes 2 by 13 T, or T is equal to 13 by 2 K. This is the relation between K and T. Next we will apply this equation to the second situation, student. Let us write it. In the second situation, the initial temperature is 80 degrees. So this is 80 minus 60 by T is equal to K into 80 plus 60 by 2 minus 20 degree the room temperature. Okay student. So this is K into 80 plus 60 by 2 means 140 by 2 70 minus 20 means 50K, and 50 into K, what is K? K is 2 by 13 T. Okay student, 2 by 13 T. So this is 100 by 13 T, and what is this? This is T prime, say the second time T prime. Okay student, or we may say T1 or T2, or whatever we may write. Let us write here T prime. So 80 minus 60 means 20 by T prime. The time taken in the second situation is equal to 100 by 13 T. So what will be T prime, student? The T prime by 20 will be equal to 13 by 100 T. Okay student. So student, this 20 cuts this by 5. So T prime is equal to 13 by 5 P. So option C is correct, students, for this question.